Hello and welcome. I want us to have a look at function machines and how we represent functions machine from an equation, especially a linear equation. This is functions applying for junior students, that is students at junior high school, which is also called lower secondary school in Cambridge. It might be different from the IGCSE function and also from A-level function. After all, this is the foundation of function, and the IGCSE is different, and which we'll have a look at. So, how do we represent an equation as a machine? And therefore, if you're having a question like this, one of the things you need to identify is the input and the output, and if there are operations. In this case, we have an equation where x was multiplied by 2, and then 3 was subtracted, and it gave us an answer y. So the answer is always called output. And x, for this case, is the input because it's the only unknown that we are having now, is the input. And then the operation that we have here is multiplication by 2 together with a subtraction of 3. So let's just draw this function machine very quick. So I'll have my ruler here. The program of function machines are sometimes a little bit easy, but not that easy. So let me just be a little bit quicker. I'll not use words. So we have two operations. So let me just use the two operations here. And then we are going to have output. So for machines, we don't really need to give a lot of information. We just need to write them in the simplest way we can. So for this case, we're going to have an output here. Let me just remove this is and then we have this one, and that goes to the output part, and this is the input. So for the input, we can just write in. So what happened? It was multiplied by 2. The x was multiplied by 2. So we can write multiply by 2 here, or you can write in words. And then after that, 3 was taken away from that. And the answer we got was y. So it's the output. As simple as that. Or maybe let me make it a little bit harder as I like, and then we solve it. Look at this. We had an input and an output. Y is the output here. Y is our output. You can see it's the result of the operation. So this is the output. And x is the unknown input. And then we have x multiplied by 4, that is one operation, added to 2, and then the total answer was divided by 5, meaning 5 should be the last operation, a division by 5. I'll do the same. So that means we have 3 operations. So I'm going to make my machine this way. I'll make it a little bit longer because it's having a lot of operations. That one. And then we put the other one somewhere here. Well, I'm drawing them this way just to save on time. So this is the input part, and then the output part is somewhere here. So let me just use those ones. So this is the first operation here. So, and then there is the last one here. Just to make things a little bit easy, we said instead of writing y, you just write output, and instead of writing x, you write input. So that is input, and this is output. Of course, for the output, you can put an arrow. There is also the inverse you can do. Now, in this case, You have our input is x, we multiplied it by 4. After multiplying by 4, we added 2. And lastly, we divide the answer by 5. For example, if someone says, let's say our input was 4, let's say x was 4. If x was 3, let's say x was any number. Let's say x was any number that can come to my mind. So x was 4. And then that means that we are going to do 4 times 4, which gives us 18. Sorry, 16. And then from there, we are going to add 2. So 16 plus 2. And that is going to give us 18. And then from there, we're going to take 18, divide by 5, and it's going to give us, of course, you can put it in fraction form. 5 goes into 18 3 times, and then there is a remainder of 3, which we can put it as 0.6. So that one makes more sense. So 3.6. So our output becomes 3.6. You can do a lot of practice on how to draw function machines, and they really, really help in passing checkpoint examination. Thank you very much.